So today I'm going to talk about 322 and 323. What is a log? Specifically, how do you translate between log and exponential form? And the second part of this is graphing logs, which we will use those translating skills to do that. So in your flip book, if you go to 322, we'll be at the top. A couple things about a log and the definition of it. The definition of a logarithm is this: if b is greater than 0, then log in the base b of x equals y means b to the y equals x. Some of you remember this in different ways. Some of you use the idea of BAP. Others view bacon and eggs, base answer exponents. Another way of looking at it, the way I used to teach my students at Hawthorne, was using the circle. B to the y equals x. You can also write it the other way and go backwards, bx equals y. If you look at it, though, what's really happening in the math is the bases are staying the same. So all that is switching, if we back up, b and b are the same. So all that is switching are my x and my y. Now this is not a coincidence. The reason they're switching is because log and exponential form, these two are inverses of each other, which you can tell here. So you can see my x's and y's switching. That's why we switch them, because they're inverses. Each form is valuable for us kind of in different contexts. Now, if we look at this in 2 or 3 different ways, there's going to be some different forms we're going to see this in. The first is log of x. Log of x is equal to log base 10 of x. This is called base 10. And the reason we call it base 10 is because of the base 10, but you'll normally see it written like this. And the reason so if you see something that says log of x, you assume the base is 10 because we operate in a base 10 number system. Okay, I think the Mayans operated in a base 6 or base 20, so it's a different number system. But for our sake, if you don't see a base, assume it's 10. The second form we're going to look at is ln of x, which is log base e of x, and we'll learn what e is later. And we call this base e, and ln simply means the natural log. And we use that a lot in calculus, because you're going to see later in the course, e allows us to do some special things with infinity. Now, back to the inverse, kind of a graphical way of seeing this. We looked at this last class with inverses. If an exponential function, if we were to graph this out, and an exponential function looked something like this, we know our line of symmetry for an inverse is at about the line y equals x. We're going to translate it over this. So our exponential function will do this. Our log function then will be reflected about this line. It will look something like this. This is your log graph, and this is your 7th graph in your toolkit now to add. It's flipped over the line y equals x, and it has some special properties too, which we'll see kind of in the next section. Now, before we move on to graphing, we need to make sure we can translate, at least simply. So we're going to rewrite in exponential form. And we're going to look at a couple examples. The first one will be log base 4 of 64 equals blank. And then we'll look at a couple others. So the answer to this is 3. If we use that circle, the reason we know this is because 4 to the 3rd is equal to 64. Again, the bases stay the same. but the x's and the y's switch because it's the inverse, so that's exponential to log. We'll look at one more example of this, a little bit trickier, kind of combine 2 and 1 here. Let's say log base 3, log base 16 of 1/4 equals blank. This one's a little bit more tricky. We look at the relationship between 16 and 4. We know it's 2, so we're squaring it. Or actually, it's actually not 2, it's 1/2. And because it's flipped, it's going to be negative 1/2. So if we write it here, 16 to the negative 1/2 will equal 1/4. The 1/2 is the square root, so that square roots it, and then this guy flips it and makes it a fraction. So those are the two differences between these two. Okay, that's a way of seeing it. So we're going to be translating when we go and move on to graphing. So let's look at graphing. So graphing logs will go at the bottom. Graphing laws. So we are going to start with a parent graph. We know what the basic shape looks like now that we know the inverse. And we'll say graph the parent function. Graph the parent function. We have y equals log base 2 of x. Now to do this, unfortunately, we have to make a table, and it's because of our base. All the other graphs we learned in this course, you really don't have to make a table for. You can think about it more conceptually, but for this, it's going to be helpful if we build a table. We have x, we're going to have our y, and then we'll do our log base 2 of x here. Now the question is, what numbers do I choose? Well, you can't choose 0 or negative 1 because there's an asymptote that's blocking it, but we can choose the number 1. You will always choose 1. And your next number is always your base, which is 2. And then our third number is our base squared, which in this case will be 4. So it actually all has to do with what our base is. So now if we write this in, it won't seem as random why we use those numbers. Log base 2 of 1, log base 2 of 2, and log base 2 of 4. Now we're going to evaluate these. And I get 0, 1, and 2. 2 to the 0 is 1, 2 to the first is 2, and 2 squared is 4. So now I can move over to my graph. And we're going to graph these. I'm going to probably have to make some marks here. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I'm going to go by 2s. Or go by 0.5, excuse me. 3, 4, 5. Oops. And 1, 2, 3, 4, and 5. Alright, looks like Christmas. So, we can graph this function 1, 0. So we start here, 1, 0, our next point is 2, 1, and our last point is 4, 2. So with those points, we're drawing our curve. So we'll go up, and this is going to continue down. It's going to get really close, but it's not going to cross. There's actually an asymptote here at x equals 0. And now it's time to do our domain and range. So on this function, our domain is negative infinity, not negative infinity, 0 to positive infinity. And our range, negative infinity to positive infinity. Alright, now it's not going to be that easy on your quiz. I'm going to have you translate this. Of course, it's got to be some more fun than just doing that. So for b, let's say I gave you 3 log base 2 of x. So same parent function, because my base is 2, but now I'm looking at 3, and I know this is a vertical stretch. By a factor of 3. So I can go back to my parent. If I go back to my parent, I'm going to stretch this, each point by 3. Now it's a vertical stretch, so we're going up and down. So it's my height. So my first height, if this is at 0, will stay at 0. Second point's at 1. I'm going to stretch it by 3. 1 times 3 will bring me up here. And then this next point's at 2. 2 times 3 is 6. 5, 6. Alright, now I can go ahead and draw this in. Notice my domain and range don't change. We're just being stretched by a factor of 3 here. Oops. By a factor of 3. Alright, so there's no shifts, domain and range stay the same. Now let's look at one that's a little bit different. Let's look at part C here. So part C, a little bit more challenging. Negative log base 2 x plus 4 plus 1. Now what's important here is to notice the order. So we have 3 transformations, the negative, the 4 to the left, and the 1 up. So we got to think order. Parentheses first, so we're going to do this move first, then multiplication next, then we flip it, and then the third move is to shift it up. So I'm going to go back to my parent graph, which is my blue graph. I'm going to move every point first over 4. So 1, 2, 3, 4. And you might want to do this in a pencil so you can erase. Do the same thing with the next one. 1, 2, 3, 4. And then move this one over 4. We're here. Now, we have done my horizontal shift of 4. We're good. Now the next part of this is to flip it. So we're going to do the flip. So we're literally going to flip right over the x-axis. So now you can see this symmetry here. So I do not need these points anymore. Alright, so I flipped it, and then the last move, and I'll do this in a different color, do this back in my orange, is to shift it up 1. So I flipped it, or I've moved it horizontally. I flipped it now. Now I'm going to shift each point up 1. And before you draw on this new curve, it's important to draw on your asymptote. So because I know my horizontal shift is 4 to the left, the vertical asymptote is going to move with it. So my new vertical asymptote will be right here at negative 4. So my new asymptote is at x equals negative 4. And the reason we do this first is now it will allow you to run that curve, that orange curve, right along it without passing it. I do this, come down, oops, then come over, and that's my new graph. And the black points are that last, right before the last shift. So now we can write our domain and range for this guy. The domain will change. It's not 0 to infinity anymore, it's actually negative 4 to positive infinity. My range remains the same. Negative infinity to positive infinity. Right? So now you can see that being the horizontal shift affecting my domain. You will have one of these on the quiz tomorrow, so make sure you pay attention to the order, but do your parent graph first.